Hi everyone, in this video we are going to practice writing a bunch of different types of standard combustion equations, okay? So we're going to actually take a chemical reaction and write down the chemical equation. So let's start off with the simplest version of this. Please write the standard chemical equation for a combustion reaction. Go. Alright, did you get an answer? Hopefully you did. This is pretty straightforward. If you stumbled on this at all, this is why you need to be watching this video. I need you to be able to pull a standard combustion reaction or equation out of your back pocket and just have that ready to go. So a standard equation for it would be any source of fuel, so just fuel is fine, plus oxygen. Typically we would say oxygen gas, and then we create carbon dioxide gas, and then water. Now the thing is, depending on who you talk to, their phase is going to be different here. We can say gas for all intents and purposes here. Some people are going to say liquid. If you talk about the opposite form, when we're talking about more of photosynthesis instead of combustion, we definitely would say water's in the liquid state, but for my sake and for this course, I'm totally fine with you picking one or the other, so that's fine. Alright, so now that we know the standard notation, please write the combustion equation for methane. So you need to come up with all the different reagents, you need to write out the equation, and then you need to balance it. Go. Alright, did you get an answer? Hopefully you did. The very first thing that you had to do was write out the standard combustion equation and then use methane. So methane is the very first hydrocarbon that I ask you to memorize, and so you have methane plus oxygen going to create carbon dioxide and water. Now you can go through and put the phases in here if you want. I'm not too particularly concerned with that. What I'm mostly concerned with is whether or not you can come up with that and now balance it. So let's go ahead and balance this. So I see one carbon on my left, one carbon on my right, that's fine. 4 hydrogens on my left, 2 on the right, so I'm going to add a 2 right here, so now I have 4. Now I see that I have 2 oxygens on my left and 1, 2, 3, 4 oxygens on my right, so I'm going to add a 2 here. This looks balanced to me, but I always go through and double check. Carbon, carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 1, 2, 3, 4 oxygens. This is a balanced methane combustion equation. All right, let's try another one. How about ethane? Please draw out the ethane combustion equation. Alright, did you get an answer? Hopefully you did. This is basically the same exact thing as we did in the last question, except for instead of methane, now we're doing ethane. So ethane is the second hydrocarbon that I asked you to memorize, and so we need to know that our source of fuel, it would be C2H6. We would treat that again with oxygen gas, and then we're going to try to create carbon dioxide and water. So now we have our standard combustion equation. We need to balance it though. So I see 2 carbons on my left, so I'm going to put 2 carbons here on my right. Then I see 6 hydrogens on my left and 2 on my right, so this is going to become a 3. Now I see that I have 2 oxygens on my left and 1, 2, 3, 4 here plus 7. Yikes. Okay, so, or sorry, plus 3 to give us 7. We have 7 oxygens on our right side and then 2 on our left. So the best thing to do whenever you're balancing a combustion equation is just do it in terms of halves for your oxygen. So you basically use your fraction to say 7 halves, then you don't have to kind of worry about how am I going to get these numbers to work. But never leave it like this. You always multiply by 2. Get rid of that fraction. So I'm going to take this entire thing and multiply it by 2. So this now becomes 2C2H6 plus 7O2 going to 4CO2 plus 6H2O. Alright, so let's check that. We have 4 carbons on the left, 4 carbons on the right. We have 2 times 6, so 12 hydrogens on my left, 6 times 2, so 12 hydrogens on my right. Then I have 7 times 2, so 14 oxygens on my left. Now 4 times 2 gives me 8, plus 6, so 8 plus 6 gives me 14 oxygens on each side. So we do have a properly balanced ethane combustion equation, so that's good. That makes me really happy. Let's try one more. Okay, and so this is another one. For some reason, people mess this up all the time, but I think it's because they overthink it. So just try it, okay? The hydrogen combustion equation. What do you come up with? All right, did you get an answer? Hopefully you did, and all you had to do was just determine that hydrogen was your source of fuel, so that's your H2. You're going to treat it with oxygen, and then create your carbon dioxide and water. But the first thing you're going to realize when you try to balance this out is that we have carbon on my right side, but no carbon on my left side. So this obviously cannot be a proper combustion equation for hydrogen. So what you need to realize is that you just simply erase that carbon dioxide component, and so your only product is actually just water. So now that you have your combustion equation, you just balance it. 2 hydrogens, 2 hydrogens, 2 oxygens, 1 oxygen. So this needs to become a 2. So now I have 2 oxygens on my right. So now I also have 4 hydrogens on my right. So I need to come back here and balance this. And so you end up with 2 hydrogens, 1 oxygen, and 2 waters for a properly balanced hydrogen combustion equation, okay? Know this one. Wink, wink, nudge, nudge. Good luck.